So with podcast number 8, this is also something that you use in calculus. So there might be times when you need to integrate something like this and you just can't do it. You get stuck. And so you use what's called a trig substitution. So we're going to, even though this just has algebra in it, we're going to substitute trigonometry in it and then simplify it. So the original problem says square root 64 minus 4 times x is squared. And in place of x, we're going to be using 4 sine of theta. Oh, I forgot the 4. Let me just make that 4 in there. 4 sine of theta. And then it needs to be squared. Now what I'll do is square this. So square the 4, that's going to be a 16, and then sine squared. So there's 64 minus 4 times, and then this will be 16 sine squared. Now right here, a 4 times 16, that is going to be 64. So there's 64 minus 64 sine squared. Well, that's quite a coincidence that it's got 64 and 64. That's why that was chosen to be a 4 times sine, so that would work out that way. Now continue with simplifying. So I could factor out 64, and then it would leave 1 minus sine squared. All right, now that this right here is multiplication, you can take the square root of 64. 8 times 8 is 64, so the square root of 64 is 8. And we're almost done. So I factored out, or took the square root of the 64, that's on the outside. Now this can actually be simplified because, as I showed in podcast number 6, sine squared plus cosine squared is always equal to 1. Well, if you take that identity and you subtract sine squared from both sides, then it's going to leave that cosine squared is equal to 1 minus sine squared. So I can replace the 1 minus sine squared with a cosine squared. Now we're just one step away. So after I replace the 1 minus sine squared with cosine squared, this square root and this square can cancel each other out, and it simplifies to just be 8 times cosine of theta. And that is as simplified as it can be.